Once we have double-clicked on our system icon, we'll first have to select a project. Again, a project is simply a folder that keeps all of our data, all of our methods, and everything we do within the system in one location. If you remember back to the configuration, we created a new project called Project. So let's choose that, and then we can start running some samples. So let's first get acquainted with the control side of the system. At the bottom left, we have our two views. Our acquisition view, where we're going to run samples and look at the system and control it, and our analysis view, which allows us to open data and analyze data while we're running samples. Of course, we'll come to the analysis side of the training at a later point. Let's go back to the acquisition and get acquainted with this window. On the left side, we have our system status for each component, as you see here, as well as the information for each one of those and the current conditions. On the top right, we have the system status, which you currently see is stopped, which means we're not pumping and we're not running samples. To the right of that, we have our sequence information. As you can see, as most of the things are blank, we are not currently running a sequence or running any samples. Now, within this acquisition window, we have three main views. The first of which we're currently looking at is the system monitor. As you'll see, this is very similar to the system information over here, except that you can click on the wrench and screwdriver for certain components and change the settings on the fly. For instance, if we wanted to change the pump flow rate or the pump max pressure, we can change that by typing in the number and click OK. Now this can also be done on the fly, so that if you type in an incorrect parameter, such as an incorrect wavelength on the detector, and you already started the run, you can change that and thus hopefully get some good information. Now of course your method won't change, but for the remainder of that run, your conditions will. The second view is the chromatogram monitor. Now within this monitor, you'll see your individual wavelength, or you can look at multiple wavelengths either stacked or overlaid, and we'll see this once we start to run. And our last view is our sequence view. In this, we'll see the table, which samples are running, which samples have finished, and which samples are next to run. So now that we're acquainted with the system control side of the software, let's go ahead and start the pumps and start to equilibrate the system before we run a sample. To do so, let's first create a method. The method is located under File, Method Editor, and it's called our control method. These same icons you'll notice are also located right here. Here's Edit Control Method, so let's go to that. We'll first start by setting up the method. We'll then start running that method to equilibrate the system, and of course after that inject a sample. So, similar to the configuration, we're going to first select the components that we have in our system, and you'll notice each of them has a model name next to it. Simply check those boxes, and you'll notice for each component you now have a tab. So we'll first go through our configuration, and then we'll change a few of those to show you what your configuration control may be. With the auto sampler, and most of the auto samplers are very, very similar, there are very few settings to change here. The injection mode is the first, where you can do, of course, a normal injection. You can do any kind of pre-column conditioning, dilutions, or zero sample loss. The sample preload time is 1.5 minutes as default. Now this condition means that with 1.5 minutes to go in the current analysis, the autosampler is going to start preparing for the next injection by picking up the sample 1.5 minutes before the current run is over. Thus, it can inject almost immediately after your method is finished. You can look at that as an inject ahead type feature. The number of flushes, of course, is the number of needle flushes that the autosampler does. In any one of these windows, you can left click and hold to see what values you can actually put in. For the number of flushes, you can put anywhere from 0 to 6. The injection delay time simply means if you don't want to inject at time 0, for instance, if you wanted to start your method and then have the sample inject after 2 minutes, this is how you'd set that up. Otherwise, as most expect, you will inject at time 0, thus immediately at the beginning of the run. Let's go to the pump tab. So in the pump tab, we have on the left side our initial conditions, and on the right side our time program. Our time program will be where we change conditions, such as gradient changes or flow rate changes. But let's start on the initial condition side. The first thing we'll select is the pump mode. If we select this drop-down, you'll see quite a few options. The first 4, ISO 1, 2, 3, and 4, is just for isocratic pumps. If you have just one isocratic pump, such as the PU2089, you'll select ISO 1. If you have 2 isocratic pumps, 3 or 4 isocratic pumps, simply meaning they're all individual, you'll set the flow rate of each, you select the appropriate number you have. For instance, if you have 2, you'll notice that you now have pumps 1 and 2 available, while number 3 and 4 are grayed out. If you have 4 isocratic pumps, you now see 1, 2, 3, and 4 are active. Again, isocratic pumps mean they will not be mixing, but they'll all be set individually by flow rate. If you have 2 pumps, such as PU2089, 2 of them, mixing together at high pressures, you'll select High Pressure Gradient 2, HPG2. Again, that means 2 pumps mixing together into a mixer. If you select that, you'll notice you now can enter in the percentage of A and B, as well as the total flow rate. If you have 2 pumps mixing together and 1 isocratic, select HPG2 plus ISO 1, and you'll now notice pump number 3 becomes active, and you can set that flow rate. The reason pump number 2 is not active as pumps number 1 and 2 are acting as one pump under the HPG2 setting. Now the next step is to create a method, and then of course we'll start that method pumping so we can equilibrate the system and shortly after inject some samples. So first we have to create the method. Go to File, Method Editor, and you'll see the control method. You'll also notice that these icons on the left are the exact same icons you see right above in the background. So our control method editor is right here. If you click Control Method, you'll have the pop-up shown. Similar to the configuration, you'll select the components that you have configured in your system by checking the box. You'll notice each of those configured have the model name on the right side. Of course, yours may look different than this, so again, check the box to each of the components you have configured. So we'll first go through the configuration we have, each of the components, and then we'll add a few additional ones to tell you about the components you may have on your system. So first tab is the auto sampler. Under the auto sampler tab, you have the injection mode, which can be normal, which is just a simple injection. You can do pre-column 1, pre-column 2, dilutions, or 0 sample loss settings. For more information on that, you can go to the Help menu. The sample preload time is default set at 1.5 minutes. This sample preload time means if you're running a sequence with 1.5 minutes to go in the current run, the auto sampler will start to pick up the next sample and then can inject almost immediately after the run is finished. Of course, you can set the number of flushes. If you left click and hold, you can see the number of values you can set, anywhere from 0 to 6 flushes. And the injection delay time simply means if you don't want to inject at time 0, you can inject after the method started, for example, after 2 minutes. As with most methods, we want to inject at time 0. The next thing to notice is our method time. Depending on how long we want to set the method, we can type that in up here. For example, in our method, we're going to run for 5 minutes. So let's go to the pump tab. Now within the pump tab, you'll notice we have 4 different pump options, as you remember from the configuration, and a valve and event. What you currently see is the initial conditions on the left side and our time program, where we can change to gradient parameters or change the flow rates over time. We'll start in initial conditions. Our pump mode is the first thing to select. If we show the drop down, we have many different configuration options. ISO 1 through ISO 4 simply means you have 1 to 4 isocratic pumps, all individual, non-mixing, and you'll set the flow rate for each one individually. If we select ISO 4, you'll notice now that pumps 1 through 4 are all active, and we can type in a different flow rate for each one. HPG2 means high pressure gradient mixing with 2 pumps. So if you have 2 PU2080s and a mixer, you're going to select HPG2. What you'll notice in this setting is those 2 pumps act as one, and you set a total flow rate and then a percentage of A and B. Should you have an additional isocratic pump or 2 additional isocratic pumps, select that, and you'll notice now you have those 2 pumps available where you can set the flow rate of each one. If you have 3 pumps all mixing together at high pressures, you have HPG3, high pressure gradient mixing with 3 pumps. If you select that, you'll notice again you set the total flow and then the percentage of A, B, and C. Should you have an additional isocratic pump, select HPG3 plus ISO 1, and you'll notice pump number 4 now becomes active, and you can set your flow rate. If you have the low pressure gradient pump, PU2089, that we do have on this configuration, you'll select LPG1. What you'll notice is again you set a total flow rate, and now we have our percentage of A, B, C, and D that we can set on the left. And you can always, with all of these pump conditions, tell the actual solvent name in the boxes to the right. Now if you had additional isocratic pumps, as well as this PU2089, you would select one of these below, and then you could set the individual flow rate of each of those pumps. Again, our configuration simply has the LPG1 PU2089 pump. Now, if we wanted to create a gradient, we may start at 5% B, and over 10 minutes, we want to increase the percentage of B to 95%. And you'll notice that our gradient starts at 5 and goes up to 95% over those 10 minutes. You of course can change your C and D solvents in these cases because we have all 4 of them available to us on the PU2089. If you'd like to maintain that 95% B for 2 minutes, for example, you'd set it in this fashion. If we'd like to then equilibrate the system back to our initial conditions of 5%, we can set this, and of course this method would be possibly 15 minutes or longer if you need longer equilibration times. So this is an example of how you build a gradient, whether it's with the LPG1 or any of the high pressure gradient mixing solvent pumps. In our case, we're running isocratic, so we'll simply highlight and delete those and change our method back to 5 minutes. And now you'll see our B solvent stays at 5%. Now in this particular method, we want that isocratic at 75%. Now, the detector we have configured on this system is the 4-channel wavelength detector. As you see, we have our 4 wavelengths settable in here, and a 5th that I'll talk about in just a second. As expected, we'll set our 4 wavelengths. Now, this 5th wavelength, if we want to have a ratio of 310 to 360, we'd set wavelength 4 to 310 and wavelength 5 to 360 as seen here. Should we just want to show our 4 individual wavelengths, those 4 shown above, we can type in 0 here, and we will not use the ratio wavelength ability of the detector and simply look at our 4 different wavelengths. The last tab is our valve event. Should we have additional valves, such as the 6 solvent selector valve, the 6 column selector valve, or the 6 fraction collector valve, we'd control one of those through these first 3 valves. If we have any kind of 2-position valve or any other kind of contact closure device, we would select that through events 1 through 4. Otherwise, once we've set our method time, we save our method. You can have up to 64 characters for this method name, so you can be very specific or you can be as general as you'd like. Once you've typed in your name, click Save. You can then close this method, and now we'll start the pumps under those conditions. To do so, click Monitor, and now we're going to select that method we created by hitting the ... selecting Test Method, and hitting Open. Now once we hit OK, it will start the pumps and start plotting our data. It will continue to pump until you hit the Stop Pump button, but this 20-minute axis scale just simply means it's going to keep a 20-minute scrolling window the entire time while it's pumping. If you'd like a larger or smaller window, simply type in the number. Otherwise, click OK. Now you notice our system status says pump, and you'll notice we have our flow rate set, our pressure started to build, and our composition is 75% B, 25% A. Our wavelengths are set, and of course, because we don't have any valves connected, none of these values will change any of the valve positions. You'll see we've started to plot our chromatogram, and we're currently looking at just channel 1. If we'd like to look at all 4 channels stacked, click that. If we'd like to look at all 4 overlaid, click this. We'll look at all 4 stacked. Now while the system is equilibrating, let's go back into the method and look at some of the components that you may have. Control method. And now let's look at a few different examples. Should you have a column oven, for instance 2060 or 65, all these column ovens will be very similar. You simply set your temperature. If you have our variable wavelength detector, such as the 2070 or 75, you simply set the wavelength of choice and the response. The response is fast, standard, or slow, depending on your peak width. For HPLC, standard is default. For XLC, UHPLC is fast. And for slow, should you have very, very slow and broad peaks, you can change to slow. As with all of our detectors, the auto zero is checked so that at the very beginning of the run, it zeroes the detector signal. Should you have the PDA detector, such as the MD 2018, you have 3 different tabs available. In the acquisition settings, you have your lamp mode. This allows you to turn off a lamp should you not be using that wavelength range. If you are staying in the low wavelength range, such as below 400, you can say D2 only, and thus save your tungsten lamp. Vice versa, if you are running at very high wavelengths, such as 800 to 900, you can choose just your tungsten lamp. Otherwise, you can leave it with the deuterium and tungsten, and it will use both lamps, and you'll have a full wavelength range. You can set your slit width. Of course, you can set the range of your PDA, anywhere from 190 to 900. If you're only looking at a small window, such as 200 to 400, you can type those in, and that'll minimize the data file size. You can also set your wavelength interval, as well as your wavelength accumulation, and the sampling, number of points per second. And at the bottom you have your response, again, similar to on your UV detector, depending on the width of your peaks. And you have the baseline correction ability, should you need to do and use that. If using that, you'll set your wavelength that you want to offset as a baseline. If you're not using it, you don't have to type that in. And again, our auto zero is checked. For more details on any of these options, go to the Help menu. The next tab is the channel settings. This is where we can tell it what particular wavelengths we would like to extract and look at during the run. There are 2 options, digital channel and virtual channel. You'll see there's 4 digital channel options, and a digital channel simply means the detector is going to look at that particular wavelength just as a UV detector does, taking that particular wavelength's data point and plotting a chromatogram. The difference, a virtual channel of that same wavelength will first look at the spectrum at that particular time, and then it will take the data point from that spectrum. As you'll notice, there's very little difference between the 2, so you can choose either option that you'd like to view. And you have multiple chromatograms available, multiple wavelengths you can show. Should you have analog connections going to either a strip chart recorder or another data software, you can set the wavelengths of those 2 analogs to the bottom here. And the event tab, should you have any external events connected to the back, such as a 2-position valve or any other contact closure, you can control those through here. Our CD detector, such as the 2095, you set your wavelength anywhere from 220 to 420, the response as we've discussed, and with the CD, your polarity, whether that be positive or negative. You can also set your gain and the output mode, whether that's absorbance or G factor. Your threshold and your CD range, as well as the UV range, can be set, although the CD and UV range are for strip chart recorder connections. And you can set the scan speed when you're scanning the wavelength ranges, should you do on-peak spectra. Again, for more of these details, you can click on the Help menu. And as always, our auto zero is checked. For our fluorescence detector, such as our FP2020, you set your excitation wavelength from 220 to 900, your emission wavelength from 220 to 900, as well as your gain, 1x to 1000x, your response, as we've shown before, and the attenuation, which is only useful if you are connected to a strip chart recorder. Our auto zero, of course, is checked as well, so we zero that signal at the beginning of the injection. Our ELSD detector, you set the LED percentage, your gain, the temperatures of your evaporator and nebulizer, the gas flow, and the response, and of course, it's always good to auto zero at the very beginning. Our refractive index detector. You will set the response as we've done in the past. Our polarity, as refractive index, can have negative or positive peaks. The purge valve, as it is refractive index, we're going to want to have the sample and reference cell equivalent. Thus, when a peak comes through, it will sense the refractive index difference or change and show you a peak, positive or negative. You can turn the purge on or off, with purge meaning that it will purge both the reference and sample cell to equilibrate the detector. When it is off, it is simply flowing through the sample side of the flow cell. And your range, if you're connected to a strip chart recorder, can be set here. Our OR detector. You set the response, as with most of our detectors, a polarity, as we can have both positive and negative peaks, the gain as well, and the range should you have a strip chart recorder connected. With our last detector, the chemoluminescence detector, we set the response, the gain, and then again attenuation should we have it connected to a strip chart recorder. Again, with all of our detectors, should you have more questions, you can go to the help menu within that tab of the detector and get those answered. And lastly, as mentioned, we can have a back pressure regulator or multiple back pressure regulators if we're running a supercritical fluid chromatography or supercritical fluid extraction system. So let's look at what settings we have available. We have our back pressure that we set anywhere from 0 to 500 bar, 50 megapascal. We can set our temperature from 30 to 80 degrees. And again, we have some events should we have any external valves or contact closures. And we can set the control mode between SFC or SFE. Should we need to change the back pressure over time, we can set that on the right. If we'd like to increase the back pressure, we can, or decrease it if we'd like. Otherwise, leave this blank, and the pressure and temperature will stay constant throughout the method. So that goes through any additional components you may have on the system. The pumps and the auto samplers are all going to be very similar settings to the ones we've shown previously. Again, if you have additional questions, you can go to the help menu or contact one of your customer support representatives.